Welcome everyone. I'm Jordi Casas. I lead the Systems Product Management team at HP 3D Printing. We are so pleased that you could join us as we explain some exciting news and give you an early look at our latest multi-jet fusion advancements before announcing them to the rest of the world. Before we enter into the details, let me share the strategic background of what you are going to see. At HP, we have two interconnected strategic goals that guide the way we build our product roadmap. First, we want to help our customers develop new applications, and second, provide them with the solutions they need to scale. The solution we are presenting today is the result of our joint experience with our customers and some of the learnings we have acquired during our common journey adopting additive manufacturing. While we have been together with you developing applications, we have seen firsthand how unique each company approach is to their various applications. Even with the same geometry and functionality, two different companies may want to prioritize different set of attributes. That's also true for the different volume needs. Today, we're going to present the new HP Jet Fusion 5600 3D printer series, a solution that responds to our two strategic goals: find the right recipe for your applications and volume needs. What you are going to see now are some of the highlights of the new 5600 solution. However, our intent is that after you view this event, you connect with the HP sales team or partners to learn more about our product. So, let's get into the details. I'll now pass you over to Liz Storstrom, 5600 Series Product Manager. Liz, all yours.
Thanks, Jordi. We are so pleased that you could join us today as we explain some exciting new advancements that we've made to better address our customers' needs around optimizing their additive manufacturing operations. We continue to place our customers in the center of our focus so that we can give them the products and solutions to respond to whatever operational and application requirements that they may have. So let's get started. As Jordi mentioned, at HP, we're all very familiar with the varied nature of our customers' requirements. And up until now, multi-jet fusion users have had a somewhat limited number of print modes and settings to utilize for achieving their requirements. At the end of the day, we know everyone is working to maximize the usage of their systems, as well as minimize operating costs so that their businesses can thrive. So any struggles with part quality repeatability, downtime, or the ability to achieve the results you need is ultimately a business hurdle, which HP takes very seriously. That's why today we are excited to tell you about the new HP Jet Fusion 5600 3D printing series and HP 3D process development. Together, these solutions will allow you to enhance your overall additive manufacturing setup. So you may be thinking, okay, what is process development? Imagine that instead of running a standard print mode, you could modify your process parameters to produce results based on your specific objectives. To help explain this concept, I'm here with Manu Freire from the Research and Development Department here at HP 3D Printing to take a deeper look at what goes into developing print modes and how this applies to you. Hi Manu, thanks for joining us. So tell us, how does HP develop new print modes?
Hi Liz, thanks for having me. That's a very interesting question. Simply put, it all starts with the requirements. What are we trying to achieve? Are we looking to decrease overall build time, increase mechanical properties, fine-tune the dimensional accuracy, eliminate visual defects, or maybe even a combination of these factors? When all is said and done, it truly comes down to having a deep understanding of the processes with additive manufacturing, the parameters we can control, and what effects they may have. From there, we can experiment with varying these key parameters, evaluating which are the right trade-offs to make and achieve our goals.
Manu, how do we know if we're making the right trade-offs when we're experimenting with these different parameters? And how can we accommodate for the fact that just one print mode can't really cover all application requirements?
You make a good point, Liz. It's definitely true that one print mode will not work for all the situations. When we develop a print mode, our goal in HP is to find the best balance of properties that will work the best for the widest selection of applications. But there, of course, will be a customer that may prefer to balance the trade-offs in a different way. For instance, someone may prioritize time to part, while someone else may decide to prioritize optimal fusing.
So, what can people do to achieve optimal results based on their specific purposes?
Up until now, the only option was to run your job with a standard print mode and adjust a few key settings. But starting from now, our customers will have much more freedom, and a multi-jet function user will be able to access the same kinds of parameters we do as engineers, from layer height to amount of agent being used. So instead of just relying on the standard print modes and settings, you will now have the power and flexibility to do your own process development for your applications.
I would bet there were many folks on the call today who are excited to hear that news. And I'm sure their next question is, how? Here to help explain this is Rebecca Dake, HP 3D Printing Software Head of Product Management.
Thank you, Liz, and thank you all for joining us today. One of the keys to unlocking new possibilities with the new HP Jet Fusion 5600 solution is the HP 3D process development software. With the new HP Jet Fusion 5600 3D printer, customers can access all the power and science behind HP's 3D printing technology with the HP 3D process development software. Achieve greater control over productivity, cost, and quality settings by accessing a collection of process parameters that you can fine-tune for your application and for your business. And with more access to the full power and science of HP 3D printing technology with HP 3D process development, expand the number and type of applications you can produce using 3D printing. HP 3D process development can be found in your secure HP PrintOS account. Inside the tool itself, you can create a library of experiments, allowing you to fine-tune a series of parameters, such as thermal behavior, agent usage, and dimensional control. The ability to fine-tune parameters like layer thickness and cooling time has a direct impact on your factory's productivity, as well as cost per part and per build. Create controlled experiments efficiently by using the multi-level build feature, enabling you to create up to 10 levels within one build with different parameter settings. And then validate these settings, ensuring you get a resulting successful print with the pre-flight feature, reducing the time and costs spent on 3D experimentation. Use the Key Performance Indicators feature to see the KPIs tracked on every experiment, providing comprehensive diagnostics on printer performance. And with the Job Comparison feature, compare key performance indicators across multiple jobs to identify the major contributors to part and productivity outcomes. Only HP 3D process development with this full set of features gives your additive manufacturing operations true control and scalability.
Thanks, Rebecca. Now that we've seen an overview of the HP 3D process development workflow, let's take a look at some use cases. So Manu, what's one example of how a customer might use process parameters to achieve a specific goal?
Well, we first need to consider what the goal is. One example is to reduce time to part. We can do this in a couple of different ways. First, we can reduce the cooling time. While you can do this today, process development allows you to set a specific cooling time for a job, and even lets you track the results. And within the printing process itself, we can increase layer thickness and modify the recoater speed. Keep in mind that you also have to consider how these different parameters interact with each other.
I like this example because it's easy to see how establishing a recipe with a fast time to part could benefit a wide variety of MJF users. Anyone from a parts provider doing prototyping runs to internal model shops who require that fast turnaround on their orders. What about if a user wants to generate end-use parts for a product? That would mean they want to prioritize part quality, right?
This is actually one of the main reasons why using process development is helpful, because you can experiment and log in a process to then use for the final production. And when it comes to part quality, there are many different aspects that contribute. We have tested internally to see how we can improve surface finishing, reducing the risk of surface defects such as rugosity or roughness. A key process parameter we found that contributes to this is the amount of detailing agent we used in parts. Thankfully, with process development, we can unlock the detailing agent usage. This means that we can adjust it by different amount in different areas of the part, instead of one singular value across the whole build. So, in this example, we increase the amount of detailing agent on top of the part until we remove all the defect.
Okay, Manu, so we've talked about surface finish, but what if instead the priority is dimensional accuracy?
We now have more options than ever to fine-tune the dimensional accuracy. First off, we have the new device-specific and job-specific tuning processes that already help you to achieve more accurate parts as a baseline. And now, with process development, you can access additional settings that weren't available before. Take this part as an example. It has many small internal features we want to optimize, making the edges of the internal holes cleaner and crisper. Our first step was to lower the white powder temperature and increase the outer detailing agent usage to ensure no thermal bleed. Next, we position these parts in the XY plane and adjust the internal XY offset value to achieve the best dimensional accuracy.
Excellent. Thank you for being with us, Manu. Fine-tuning dimensional accuracy is definitely a common objective amongst additive manufacturing users. We've already had the opportunity to work with a few customers so far, seeing what they could accomplish with HP process development and the 5600. And the results have been staggering, with anywhere from 15 to 50% increase in yield depending on the application and the different parameters that were changed. As Manu mentioned, process parameter tuning is only a part of the reason why our customers were able to achieve these results. The other key piece is the repeatability and reliability of the platform itself. So to that end, we'd like to introduce the HP Jet Fusion 5600 series 3D printer. This latest generation HP Multi-Jet Fusion system has been designed for dependable manufacturing that allows you to maximize productivity and flexibility. This new solution uses a combination of updated print modes, hardware, and calibrations to improve part quality and repeatability, ultimately helping you to increase yield rates and operational costs. We've seen a number of improvements in part quality, including over 50% reduction in variation for both part density and tensile strength. This not only reduces the risk of time-consuming and costly reprints, but it also opens up new possibilities in terms of the applications that our customers can take on. In addition to part quality, you can also expect a boost in system reliability since we leveraged the 5200 series architecture and made a number of hardware enhancements focused on extending the lifespan of critical components. This combination of yield and uptime improvements directly help you to increase your overall equipment effectiveness, otherwise known as OEE. And lastly, the 5600 series provides expanded data access with the added option of taking advantage of our new process development capabilities. And by completing your full additive manufacturing setup with automation, you'll be able to further improve operational efficiency. As announced earlier this year, HP's newest automation capabilities include the HP Jet Fusion 3D automation accessory for automatic exchange of build units, and the HP Jet Fusion 3D powder handling automation solution for more efficient and high-volume material management. With all of these solutions, you can now achieve whole new levels of productivity through reduced costs, increased operational efficiency, and true process flexibility.
Thank you, Liz. Now that you have heard about these latest advancements, we hope it's clear that we have been listening closely to your feedback. Our development teams have been working very hard to keep pushing the technology's capabilities forward, so that you can have the power to either scale existing applications or develop brand new ones that were not possible before. We are committed to being your trusted global partner in industrial additive manufacturing and are here to ensure that you get the most out of the HP 3D printing solutions. To learn more about any of the systems or capabilities we discussed today, please reach out to your HP contact for more information. You can also review a summary of these solutions and contact HP directly from the website at the bottom of the page. Thank you for your time today, as we share this sneak peek of what will be announced more broadly at Fornex in Frankfurt. We look forward to seeing you there.